Today we begin with the third chapter, that is current electricity. Okay. Now whenever the charges are in motion they constitute the electric current. We have an example that in lightning charges are flowing from the clouds to the earth through the atmosphere. Now the flow of the charge in lightning is not found to be steady. Okay, because there is no steady current which is flowing from the cloud to the atmosphere. It changes every now and then whenever there is a lightning. But in our day to day life, we have seen many devices in which the charges are flowing in a steady manner. We have an example, that is torch, which is run by the cell. Now, what is electric current? Because first of all, we should understand the concept of what is current, what is flow. Flow of anything is a current. Say for example, if you have a fluid or say water which is flowing through the pipe, then it is a water current. Okay. If say for example 5 liter water is coming out from the cross section of the pipe in say 1 second, then we can say that the flow of water is 5 liter per second. Similarly, if the net amount of charge which is flowing through the small area normal to the direction of flow, so we consider, say for example, this is our pipe, or we can say this is our conductor wire, and the charge is moving perpendicularly to the cross section. Say for example, this shaded region is the cross sectional area and charge is flowing perpendicularly to it. So the net amount of charge which is Q, say the amount of charge flowing is Q, which is flowing through the small cross sectional area. This is our small cross sectional area normal to the flow of electric charge. Flow of electric charge is in this direction and this cross section is perpendicularly or perpendicular to it. Say in this forward direction these charges are moving, that is in this direction, in say time interval of t. So we can say q amount of charge is flowing perpendicularly to the direction, or we can say perpendicularly to the area. Okay, so q amount of charge is flowing perpendicularly to area in how much time? In time interval t. Okay, so we can say that the net amount of charge per unit time. So charge, how much charge has passed? Q amount of charge. In how much time? In time interval t. So Q upon t, that is charge in unit time. So charge in unit time, that is defined as electric current, or we can say the current I is given by charge upon time, that is Q upon T, which is having its unit coulomb per second, because charge is measured in coulomb, time is in second, or this unit is called the ampere. We can define it in a different other way. Say delta Q amount of net charge is flowing across a cross section of a conductor during time interval delta T. Then current at any time t through that cross section is defined as the ratio of delta q to delta t, or we can say delta q upon delta t, that is given by electric current, or when time interval is taken very small, that is limit delta t tends to 0, then I is equal to limit delta t tends to 0 delta q upon delta t, which is nothing but dq by dt, or it is known as time rate of flow of electric charge. So time rate of flow of electric charge is also defined as electric current.